graphing a polynomial from its factored form. So if we look at this polynomial here, you can see you have a double root, a distinct root, or a single root, and another double root. Okay, so the first thing you want to think about is like, what's the actual power of the function? Well, I think of it as like x squared times x squared, which is going to be some x to the fifth degree, and that's going to be a fifth degree polynomial. Okay, so knowing that it's odd, right, it's going to have the same end behavior as any other odd function. So we know that when x cubed is positive, it looks like this. So what that really means for this fifth degree polynomial is that it's going to start at negative infinity and end at infinity. And now we have to kind of do the work in the middle to figure out what happens. So first thing we have here is we have x equals negative 3 is going to be a double root. So we'll record that. Then we have at x equals negative 6, that's going to be a single root or a distinct root. So let's put a single root here. Okay, and then at x equals 2, remember I'm setting each one of these equal to 0, I have a double root as well. Okay, so when I look at this now I want to go and plot all of those x-intercepts here so that I can draw the graph. Okay, so I know it's going to have to pass. It's going to actually have to come from negative infinity right down here, and then it's going to have to pass through negative 6. Negative 3, it's actually going to hit the x-axis, go back up, and then my final double root is right here, which is going to do the same thing again. It's going to hit the x-axis and go back up. So because this is positive, it has the same end behavior as a cubic function, and it's also of the fifth degree. So it's going to go through negative 6, and then I'm going to hit this double root and go back up, and then I got to hit this one again, and now I'm going to finish at positive infinity. Okay, so you can clearly see that it goes through negative 6, meaning the single root, a double root at negative 3, and then another double root at 2. Okay, let's look at the opposite case now. Let's say we already have a graph and we want to say what is the function in factored form. We want to write it out, right? Well, in order to do that, you need to just identify the roots and the nature of them, okay? So we got a root at x equals negative 5, which actually means x plus 5 would be my factor here. And that goes through, so it's going to be a single root. Next, we have a root at x plus 1 that's a double root. And that's a double root, so we're going to square it. And then here we have another single root, which is at x minus 3. So when I put my final function here, I'm just going to multiply all of these together. And we're not going to multiply it out. We're just going to leave it in factored form. But remember, like, you could write it in any order. I just happen to write it in, order from least to greatest in terms of the x-intercepts, because that's the way we looked at the problem. But you could write this in any order because it's all multiplied together. And now you have your function f of x in factored form.